If you've been following the news recently, then you probably know it's a pretty interesting time in Canadian politics. The Prime Minister has resigned, our neighbors to the south are threatening annexation, and it seems like we're going to be heading towards an election sooner rather than later. And so I thought, now is as good a time as any to get to know better the current members of Parliament. So in today's video, we're going to see how we can use AI to create a database of MPs, and later to perform some data analysis on that table. So we can answer questions like, what's the most popular university for MPs to attend? Or what's the most common job for an MP to have prior to entering politics? So let's jump in. We'll start first with our system design. If you recall from our previous video, we've already created a pipeline that takes in a Wikipedia page URL, scrapes that URL for text, and then sends it to the GPT-4o AI model to summarize that text. Now, we're going to be doing a similar pipeline today, but instead of returning a summary of the text, we're actually going to return what's called a structured output. And now, what is a structured output, you might ask? Well, in our previous video, we returned a summary, and we can classify that as an unstructured output. Basically, we're returning a string that's 2 or 3 sentences long, and the information that we want is within that string, but it's not really ordered in any manner. A structured output, on the other hand, is typically returned in a more standardized format, such as a JSON file. So we could imagine returning a structured output for the summary, and we would have key value pairs. So we would have the topic, for example, and the topic would be Mesopotamia. The summary text would go in a summary key value pair, and we could also include the URL, for example. Basically, this just allows these data points to be more easily accessible should we want to use them later in our script or in our code. We'll see why this is important later on for our use case. Once we have that structured output, though, it makes it a lot easier to write that data to a CSV file or a new data frame for further data analysis. So looking at our pipeline, for a given URL, we're going to scrape that page for text, send it to a model to obtain a structured output of information, write that to a CSV file. But we want to do this, in fact, for a list of URLs, not just a single URL. We want to do this for all MPs. The to-do list then is to create that list of URLs, send a text to the GPT-4o API, return the structured output, parse that output, write it to a CSV file, begin the loop, and then perform some data analysis. So let's start coding this thing. Now, the first thing we want to do is create this list of URLs. But let's start by understanding the structure of a given URL. I have here the big guy himself, Justin Trudeau. If we look at the URL, it seems to be comprised of 2 parts. The ending here, which is his name joined with an underscore, and then this prefix. We can check this again for another MP, let's say Chrystia Freeland, and we see the same thing. So it seems like we need to obtain a list of names for every member of Parliament. And thankfully, this is publicly accessible information. We can simply search Canadian members of Parliament and go to this site here, and here we go. And actually, if we scroll down, we see that this data is available in a CSV format. So let's download that. Once we have that downloaded, I'm going to throw it in a Google Sheet just so that we can better visualize the information we have. Okay, so we've loaded up our data, and we have these columns, so honorific title, first name, last name, constituency, yada yada. For our purposes, we're really concerned with this first name and last name. So let's insert some more columns here and see how we can transform them. Well, we know that we want the first name and last name joined with an underscore, so let's do that. And now we have the first name and last name joined with an underscore. I'll just move this column over here, and then we'll also copy in the Wikipedia prefix. We'll then do another join of this underscored first name, last name with the Wikipedia prefix to make the URL. And here we go. We have a list of URLs. And we can even see if we hover over one of these blue links, it shows us a preview of the page itself. We can click that, open it, there we go. Now we do notice that some of these URLs are not blue, but rather they're black. Let's see what that's all about. I'm just gonna copy this over into a new tab and see what happens. Okay. So this does seem to be a valid URL, although I'm not too sure why it's not blue. We can see other instances here. Let's double check that. Okay, so these seem to be valid URLs, but something's off. I'm not too sure what at this point. My suspicion is that this special character, this accented character, is giving some trouble. And that seems to be a common thread between all 3 of these guys and beyond. So right now it's not causing too many problems, but we'll just keep that in the back of our head. We also see in this instance that Lisa Marie has 2 first names, and so the URL is missing that underscore. So what we'll do here is simply replace any instances of a space in the URL by an underscore. We'll make that additional transformation, and we now see that this is a complete URL. What we want to do now is apply these transformations in a Google Colab notebook and start writing in Python. Now, in the previous video, we used Claude to help us program. Claude, of course, is Anthropic's AI model, accessible through their browser application. We're going to do something a little bit different today. Rather than accessing Claude through Anthropic's browser application, we're going to access Anthropic's AI models through their playground environment. This is beneficial for us because a monthly subscription to Claude is $28 a month. But by accessing the models on the playground environment, we only pay for the tokens that we generate there. And so we can load up our account with $6 instead and access the exact same models. It's going to save us money, and it's also going to give us more control over how we want the model to act. If you head over to the console.anthropic.com, I'm going to log in with my Google account. And the Anthropic playground works in a very similar way to the OpenAI playground, in that you do need to load your account up with credits in order to access the model. So head to the settings page, and in the settings go to billing. Now, if it's your first time signing up, your account may already be preloaded with credits, in which case you're good to go. If not, then you may have to add funds. I typically add $6 and it lasts quite a while. So once you've done that, head back to the dashboard and click Write a Prompt from Scratch. And now we're in the Anthropic playground environment. Let's recall what we want to do here. We imported this CSV file of MP names into a Google Sheet, and then we applied some transformations to them to obtain the Wikipedia URLs. So then what we want to do is import this file into our Google Colab notebook. You can do so by just dropping it in that left sidebar. I'm going to rename this to MP data, and we want to write this data to a pandas data frame. Pandas is a Python package that allows us to better handle data in a variety of ways. So I'm going to go to the console and I'm going to ask the model to do that. Okay, and it has given us this function. So let's go ahead and copy and paste that in. It also gives us some basic usage, and then it allows us to preview some of the first few rows. So let's define that function. Let's run this. Oh, and it seems like we haven't defined our CSV file. We essentially have this same information now accessible through a data frame in Python. So next, we want to apply those transformations. And what I'm going to do is simply describe those transformations in this code block, and then we'll ask the model to do that for us. So first we had joining the first name and last name by underscore. We then want to append the prefix, the Wikipedia prefix. And then finally, we want to replace any instances of a space by an underscore. And then this will give us our list of URLs, which we'll then add as a new column. So let's take these instructions over and go to our console. What I'll say is I'll give the model the head of this data frame so it knows the type of data it's working with. So I've said, great, consider the following data frame, given it the data frame, and then I've asked it, can you write a new function in a new code block to create a new column with Wikipedia URLs? And then I've defined the transformations we want it to do. Let's run this and see what happens. Okay, so it's created this function, create Wikipedia URLs. Copy that and paste it in our notebook. It has also given us a code block where we can use this function. So let's copy and paste that over as well. Okay, great. So now we have our Wikipedia URLs. Now right now we're just seeing the first 5 entries of our table. But let's say we wanted to see 50, for example. We could type in 50 in this head function here. And now we see here that this special character has come back to bite us. Let's see what this is all about. If we click on one of the URLs for René Arsenault, for example, we see that it takes us to WikiRen. Okay. And if we try another one, let's say Stéphane Bergeron. Okay, so it goes to ST. Seems like the problem is that the URL is being cut off at the special character. So let's describe this to Anthropic and see if it can help us troubleshoot. So I've described the problem I'm facing, and let's see what it says. Okay, it's because special characters need to be URL encoded. Okay, so it's an encoding issue, and that makes sense. So it seems like it gives us this create Wikipedia URLs function again, with proper encoding this time. So let's copy and paste that in and try to look at our URLs again. Redefine the function, call it. All right, and we see that the special character has now been changed to its encoding representation. One small thing is that the URLs are being cut off, so let's see how we can increase the width. Okay, and it tells us that we can control the width with these display options here. All right, so I'm just gonna paste that in, and here we go. Now we can test out our URLs to ensure their encoding is correct. So we'll press this. All right, and now that looks to solve it. We can try it again with Stéphane Bergeron, looking good. So now we have our list of URLs. Let's go to our to-do list and cross that off. We next want to scrape the Wikipedia page for its text. And if you watched the previous video, then you know we actually already have a function for that. So what I'm gonna do is I'm gonna open up that project and paste that function in. So here we have our scrape Wikipedia function, and we can test it by running this code block. Oh, looks like we didn't import the request libraries, so let's just go ahead and do that, along with the other libraries as well. Okay, and here we're scraping the page for Justin Trudeau, and it looks like we're getting back the text like we want. Now, one thing about this function though, in our previous video, we decided to remove some of these unwanted elements like tables and spans and what have you. But if we go to the Wikipedia page itself, we see that this table on the right-hand side does contain a lot of relevant and important information. And if we inspect it, we see that it does belong to the table tag. So let's just go ahead and remove the table tags as unwanted. And just to be safe, let's remove the spans as well, just in case. We'll redefine our function, we'll test it out, and here we go. We have our URLs, we have a function to scrape the URL for text, and now we need to send it to GPT-4o for a structured output. And we also need to define what we want that structure to be. So in our example with the summary, we had a topic key, the summary itself, and then URL. In our case though, we want to extract from this page important information like the MP's policy stances, or their educational background, or their previous occupation. And for well-known figures like the Prime Minister, for example, this information can be found in this table on the right-hand side. We see alma mater, occupation, even salary. If we check for a lesser-known MP, what we'll find is that this table on the right-hand side doesn't always contain those objects. Instead, they can be found in this more unstructured text in these paragraphs. So for example here, Omar Algebra's table doesn't mention that he went to York University, but instead we have to read his early life and education. And this is where AI really comes in handy. We can have an AI read this text and then extract those pieces of information. It's almost like a smart parser. Okay, so with that said, I've summarized the information in this text box here. We want to extract some basic information like the full name, years active, and current house position, and then we're going to dive deeper into things like their educational background, the schools they attended, the subjects they studied, level of education they attained, career, so the job before entering politics, and even their parents' occupation if that's possible. And then signature policy positions, up to 5 notable policy positions, and even controversial statements. And in order to extract this information, we're going to use a large language model like GPT-4o. So we'll head to the OpenAI playground and get started. Previously, we had a pretty simple task. We just wanted an AI model to summarize a Wikipedia article into 2 or 3 sentences. And so our system prompt was basically just as simple. Here it is here to remind you. We just said you're a Wikipedia summarizer, give it an article, please summarize it in 2 or 3 sentences. But now we have a much more complex task. We want to say, given a Wikipedia article, please extract all of these pieces of information and return it to us in a structured, standardized way. And now instead of us taking the time to craft the perfect prompt, OpenAI has created created this tool to take a lot of guesswork out of that process. So if you click on the Generate button, you can actually describe to OpenAI what you want your model to do, and it will create a prompt specialized for that purpose. So I'm going to go ahead and describe our task here. So I've said, given a Wikipedia article on a Canadian member of Parliament, please parse the article and return the following information. And I pasted in all of those points, and then I asked it to return the information in a structured JSON file. Now I'm going to go ahead and copy this just in case we need to use it for later, and press update. Okay, and now it seems to have generated a system prompt for us. All right, and it's even defined the structure of the JSON file. What we're going to do is test this out. Let's go to our scrape Wikipedia function. We've already scraped Justin Trudeau's Wikipedia page. So let's copy that text over, paste it into the user message, click run. Now we get to see this JSON file. The AI has given us all of these great pieces of info. So we have the full name, years active, Commons position. That seems to be pretty accurate so far. The schools attended, McGill, British Columbia. We can even search for that in his Wikipedia page. We do see that those are included. Subject studied, literature, education. Yes, Bachelor of Arts degree in literature. Politician, teacher, okay. And it's even given us the signature policy position. So all of this looks pretty good so far. Okay, great. So this does seem to be working correctly. And we seem to be receiving a JSON object. But looks can be deceiving. What we're actually receiving here is just a string of text. And the AI puts these JSON tags at the beginning and end. But there's actually no guarantee that the model will always remember to close these brackets or won't forget a comma. So what we can do to ensure that we actually receive a JSON object is go to the model settings on the right hand side. We see we have this response format parameter, and right now we're receiving text. But instead, we can ask the model to return to us a JSON object. And this should always return to us a verified JSON object. So let's see what this looks like. We'll delete this previous entry, and then we'll run it again. Okay, and now we can see, even just in the UI difference, that this is a JSON object. Okay, great. So our prompt seems to be working. Let's test it out for a few other NPs to see what we get. We can do Pierre Poilievre, for example. Scrape the Wikipedia page for text, paste that text over. Okay, and we seem to be receiving exactly what we want. We can double check some of this information. Let's see, corporate collections at TELUS. I didn't know that. All right, and it does seem to be corresponding to what is actually written in the Wikipedia page. Interesting. Okay, great. So it seems like our prompt's working. We're extracting this information. So let's transfer this over into our Google Colab notebook. We'll delete this last entry, and we'll click this code button here. And we're already in Python, which is great. And then we'll just click that copy button and paste it over. And if we press run, again, we'll run into this API key error. So I'm just going to set that up in a code block up here. Okay, so I've uploaded my API key, and what we want to do now is turn this API call into a function. So instead of hard coding this text, we'll assign it to a variable. Let's call it WikiText, and then we'll define a function. And then we'll return the response of this API call. Okay, we'll define that function, and next we basically want to test it out. So let's copy and paste this code up here into a new block, and instead of printing the text, let's call this function. So we've scraped the text, now we are extracting the details from the Wikipedia page. And now we see we have our JSON file. Awesome. So if we go back to our to-do list then, it seems like we are able to send the text to GPT-4o and return structured output. Next, what we want to do is parse that output and write it to a CSV file and a data frame. So let's describe that to our Anthropic model and see if it can help us do that. All right, so it's given us this function. Let's paste it over and then see what else it says. You can use it like so. Okay, great. Just one thing to keep in mind is that we are already using this df variable. So I'll just say df test. Okay, so let's run this and see. And now it looks like we are printing this information to a new data frame. Awesome. And let's see if we can save this to a CSV file just to better visualize it. All right, so now we've defined this new function, save data frame to CSV, and let's give it a shot. Okay, so now we should have MP info test. Let's download this. Let's go to Google Sheets and import. Okay, great. And here we go. Now we can see we have this data frame with all of these entries filled in. So schools attended, subjects, previous jobs, policy positions, controversial statements, and the Wikipedia URL itself. Okay, so if we go back to our to-do list, then we had the point parse output right to a CS file data frame. I think we can cross that off now. And at this point, we just want to put this all together. We have our list of URLs, and we're going to loop through that list. We have our web scraping function to extract the text from the page. We have our GPT-4o API call that returns to us a structured output. And we have a function to parse that output and write it to a new data frame and CSV file. So let's put it all together. Okay, so I've given it this nice long prompt where I've clearly explained each of the steps that I'd like to happen. I've referenced the functions we've already created and then asked the model to create this pipeline in a new code block. And it looks like that is exactly what it's done. Looking at this function, I mean, generally it looks to be following the steps we've outlined and gives us even an example use case. So let's copy that over, paste it in, and just review it one more time. So input df batch size. Okay, so I'm not sure I know the difference between batch size and save frequency. Let me just ask the model. So it seems that batch size just wasn't even used. And if we control F, it's an unused parameter. Okay, perfect. So always good to just double check what the model is doing in case it does those hallucinations. Okay, so I'm going to change the save frequency to 5 just so that we can take a look at our data faster. Otherwise, let's run this. Okay, and one thing I'm noticing off the bat is that we're not getting too much information as to what's actually happening under the hood. So I'm gonna stop this code block from running and ask the model to add more print statements so we understand what's happening. Okay, and here we go. Great, so now we can see which MP we're currently on and which step that we've completed. Okay, and now we should have this backup MP data complete. Let's download that, head to our Google Sheet, and let's import it to see what our data looks like. Okay, awesome. So we can see we've included the previous data frame entries, but now we have these additional columns that include the data points that we specified in our prompt. So the years active, house position, schools attended, and we see some MPs do have empty entries. So let's just double check that their Wikipedia does not in fact include that information. Here we have no schools mentioned, and yes, it does look like this MP's Wikipedia page is pretty sparse. We can do another check here. Yes, doesn't look to be any schools. So okay, awesome. And if we go back to our file, we see that now we're on number 16. I think if we refresh our files and download this again, it should be larger. Okay, and we see that by importing this file again, it's grown and we have these new entries. Okay, so things seem to be working in the way we want them to. I'm going to let it finish running and then we can review our data after. Okay, so now we can see our script has finished running and we've written the data to this MP data complete CSV file. So I'm gonna go ahead and download that. Let's throw it up in our G Sheet to see what it looks like. Okay, great, now we have our data. So looking at the data closer, we can see that some MPs have basically all of their columns filled out. Other MPs have only a few columns filled out, and some have, well, none or next to none. So let's check out why that might be happening. Let's open up Anita Anand. Okay, so she's a pretty well-known figure, and that makes sense why all of her columns would be filled out. We can go to Scott Aitchison, who has schools attended level, but no subjects, and no parents' occupation. So let's see. Okay, and it does look like his alma mater is referenced, but the subjects are not. Quite a few policy positions, so let's just double check. Okay, yeah, and it seems like those are reflected. Okay, and then going down here to someone like Michael Baird or John Barlow, like John Barlow, because he has, well, none other than member of parliament. Oh, this is interesting. Okay, so it seems like there's multiple Wikipedia pages for this name, which is something we didn't realize back in our initial step when we were assembling these URLs. So it looks like we actually want to point to this URL, John Barlow _ Canadian politician. Let's check out Michael Barrett. Okay, same thing here, Canadian politician. We have here Terry Beach, he has nothing, so let's just double check. Okay, so this is the Wikipedia URL we wanted to land on, but we didn't obtain any data for it, so I wonder why. So what I'm gonna do is I'm gonna go back to our script. I'm just gonna Control F Terry Beach. Okay, and we can see there was an error parsing that information. Expected a string, but list found. Okay, so what probably happened was that OpenAI returned to us a JSON object with the wrong format. Not the end of the world. What we're gonna do here is just sort this table, let's say by years active, just to see. Okay, so now we're starting to see a pattern here. We would expect the years active to be a rather standard figure that we could easily get. So if we don't have years active, we can assume that something fishy is going on. And if we look at some of these MPs, right, so there's two here, British Columbia and Ontario, and we're actually interested in the British Columbia one. See Ben Carr. Okay, so some even have underscore just politician, whereas others have Canadian politician. Got Sean Chen here. Okay, and this is a Malaysian actor, but we're interested in politician, Canadian House of Commons. Okay, and then even if we go all the way down, okay, and we see Terry Beach is not the only MP whose response was improperly formatted. So it seems like when we tried to parse these responses, it failed completely, so we have no data. We can double check this with Mike Lake too. Yeah, so we're kind of running into the same issue. So what we want to do at this point is just retry for these MPs. So let's close some of these tabs. And I'm going to describe the problem to our Anthropic model and see if it can write us a new function to run this pipeline for those MPs that failed. Okay, so it gives us this new code block. Let's go in here. Okay, let's run this. Okay, cool. So it's found 10 MPs with missing information. We'll hit yes. Okay, great. So then it's written this to MP data complete updated. Let's download that. And okay, it gives us the remaining MPs with missing information. So we'll just want to check those entries as well. We'll go in here, let's import it, check it out. All right, and if we do the same thing, the sort by years active. Okay, so we still see Robert Morrissey, Judy A. Let's also just check the previous MPs we had. Okay, so Terry Beach. All right, and now we see that Terry Beach, for example, is filled in. We can check for some of the others. Kevin Vuong, and now filled in. Cool, all right, awesome. So we do still have a couple of these guys down here. And yeah, so it looks like they are ambiguous and they need to be appended with some type of, it seems to be politician suffix. That's the pattern we saw with these guys. Harold Hughes. Okay. So what we're going to do next is, in order to address this group of MPs. We're going to describe the problem to Anthropic again, but this time ask it to append the underscore politician suffix. And then we'll see how many of these entries that solution fixes. Okay, so it's given us this function, and we'll copy it in. We want to run this on, updated data frame rather than process data frame. Okay, and now we can see the 37 MPs with empty years active. We go to our G sheet, count 37, all right, so that checks out, and let's run this. So we'll let this run, and we'll see how many of these entries this fixes. We can already see for these 4 here, it seems to have fixed it, but some MPs may need additional clarification in that suffix. Okay, so we've saved this new data frame to MP data complete updated years. Let's go. And it does seem like we do still have a few MPs with empty years active. Okay, let's do the sorting again. Right, so here we go. And now in order to fix this, we can look. Okay. What we could do at this point is run this same code block again, but instead of appending politician, we could append Canadian politician, and we'll import the process data frame as the one we just saved. Okay, so we still have a few MPs with empty years active, but let's check out our data now. Okay, great. So we further reduced it. And if we just check, all right, so we've got 7 here. And if we go all the way to the bottom, 3, 7, 10. So I mean, all in all, if we have 327, so I mean, we're already at 97% coverage. I think that's okay for our purposes here. Obviously, in the real world, you would want to make this much more robust. And for these edge cases, because there's so little of them, we could handle them manually. For example, we're looking for Robert Oliphant. Okay, his Wikipedia page shortens his name to Rob. I think the same thing happens with Robert Morrissey. We're looking for Bobby Morrissey. Okay, so for the most part, we have our data frame. Let's start doing some data analysis on it. And plot top schools, we want to reference this latest data frame. So we're going to do plot top schools updated DF. Okay, wow, look at that. So here we see we have this very nice bar chart now where we can see top school is McGill University, followed by Carleton, Toronto, Ottawa. Interesting. And we can see the number of MPs that have attended each of those schools. Neat. Let's ask it to do something similar, but for previous occupation. All right, here we go. So it looks like the most popular previous occupations are lawyers, followed by businessmen, teachers, journalists, farmers. And we could even ask for a chart of MPs with the longest list of controversial statements. Okay, nice. So now we see top 10 MPs by number of controversial statements. And it's even actually given us the controversial statements themselves. This, of course, is subjective because sometimes what one person would think is controversial, another would think is normal, but nonetheless, kind of neat to see. But now let's talk about the limitations of this data set. Well, one thing is that because we're having an AI model generate each of these data points, there's going to be an inherent element of randomness. And this can be most immediately seen when we look at the level of education entries. So in a new tab, I'm going to display the unique entries for this column, and then we'll sort them. So we can see here that there's quite a few entries that belong to the same sort of main group, such as bachelor's degree. And in some cases, it's really only a matter of an uppercase versus a lowercase. And what's happening is that the model is generating this entry individually for each MP. And so it doesn't know if it should just always call it bachelor's, all lowercase, with an apostrophe, or bachelor's degree, so on and so forth. Same thing can be said for, diploma. We have high school here, law degree. And so when we do our analysis, it's a bit skewed because really we would want to abstract these entries to a higher group, whether it's a Bachelor of Art or Bachelor degree, and so on. And the same thing can be seen if we look at something like the previous job as well. Let's display that. So here we see as well, in some cases, the previous job is rather to the point. We have attorney, author, auditor, teacher. And then in some cases, the previous job is a bit more verbose. There's maybe extra information that isn't really all that relevant. For example, if they're an attorney at Rogers Partners, LLP, that information can be useful, but it might go in another column, such as previous employers or previous companies, rather than previous job. But generally speaking, we have created here a data set that up to now didn't exist and does provide some informative information. We could extend this further if we wanted to include things like the official voting results from Elections Canada, which is also public data. And we could show the results for each candidate to have some more quantifiable metrics. And if we wanted to extend it further, we could even create a dashboard to serve this information for people who are interested and want to get to know better the political landscape. One of the great things about politics as well is that they actually make all of their House of Commons transcripts publicly available. These are otherwise known as Hansards, and you can check them out at this site here. And they actually already come in more of an organized format. You can check out an XML file, and it's organized by things like who's speaking, the subject that they're talking about, that sort of thing. But for the most part, there's still a lot of unstructured text here that we could probably use AI for in order to further categorize it so that it's more easily accessible to people, it's easier to understand, and who knows, maybe we even improve the system at the same time. So there you have it. We've created a database of MPs by scraping their Wikipedia pages of their text and sending it to an AI model for a structured output of information. And this is basically what a lot of businesses are trying to do right now with AI. We can imagine instead of having a set of Wikipedia pages, we have a set of customer support tickets. We could imagine sending this support ticket to an AI to extract data points like the particular product, the problem, the troubleshooting steps taken, things like that. Or if you're an online store, then we can imagine a set of reviews for a particular product. Then we could send each of these reviews to an AI model to extract what people like about the product, what they don't like about the product, and so on. And the idea here is that you could serve this information in a dashboard so that the product team or what have you can draw insights and hopefully iterate upon their product faster. AI is not just for businesses though, and I hope this video demonstrated how it can be of use to people in their everyday lives. Alright, so I'm going to clean up this Colab notebook now, and you can find all of the relevant links in the description below. That's it. That's the video.